Students, in this lecture I am going to discuss an interesting question. Whenever our PhD students go to attend interviews, they are often asked a question, what was their sample size? Whatever be their topic of research, area of research, methodology, they will be asked what was the sample size, and our students will say that it was 250 or 300 or 80, whatever, and then they will be asked justify why did you select a sample of this size, and our students are not prepared. In sociology, we do not even know that there are some technical considerations behind determining sample size. I will tell you today how to determine sample size, and this is the third lecture on sampling. In first lecture, I introduced the concept of sampling, then talked about simple random sampling. In the second lecture, I talked about stratified random sampling, multi-stage sampling and other forms of sampling, and how to minimize standard error or variance of sample estimate. Now, this is time to talk about sample size. Sample size is one of the most interesting issues of sampling theory, because I had mentioned earlier that there is a trade off between sample size and sampling error. As sample size increases, sample error or sampling error, to be more precise, declines. In general, it is said that standard error equal to sigma by root n. So, there standard error is inversely proportional to square root of n, which means as n increases, standard error decreases. But because in the denominator you have root n and not n, so you can also find that beyond a certain sample size, there is not much benefit of raising sample size in terms of standard error. So, this goes to our rescue, and we can fix our sample size at certain level. In this issue of sample size is particularly important if you are doing or if you are following a quantitative methodology. In qualitative methodology, this issue is not so important. Actually, in quantitative methodology, only you talk of determining sample size in advance, keeping certain things under consideration. In qualitative research, sample size is determined by saturation hypothesis, which means that you go to the field, you start collecting data, and the moment you find that saturation has reached, that you are not getting new data, new information, different observations or new perspectives, then you stop. So, in qualitative research, focus is more on perspectives, and in say Naxalite belt, you are conducting a qualitative ethnographic study. The focus will be more on whether you have understood things from the perspective of Naxalites, from the perspective of administration, from the perspective of police, and from the perspective of NGOs working for implementing different development schemes, maybe some under corporate social responsibility by corporate sector. It is also said that for qualitative research, you follow a general rule that research must be spread over a full year. The reason is that many rituals, celebrations, festivals, etc., take place once or twice in a year depending on agricultural season or maybe depending on weather. So, you follow that 1 year rule for ethnographic research. Number is not important. In quantitative methodology, however, sample size is one of the most interesting issues of sampling theory. And this takes us to the question, how many observations are needed for a good inference? Good inference means inference which has a low standard error, which is precise, which is dependable. Are bigger studies always the better? How many households, villages, blocks should I study if I do a study on something? In monitoring and evaluation of development programs, in examining or in exploring comprehensive knowledge of HIV and AIDS, in study of migration, in study of crime, in study of family nucleation or other sociological topics, in sociology of religion, how many subjects should I study before drawing a valid or precise conclusion? How do I justify the sample size to donors or sponsors? We researchers, when we write research proposals, we also give some sample size, and that means costs of conducting the study. Cost of conducting the study heavily depends on sample size. So, for a fixed cost, we have to justify sample size, or we have to minimize sample size for fixing a cost of overall study. Resource material for this lecture is drawn basically from these two books. I mentioned this Cochrane's book in the previous lecture also. The title of the book is Sampling Techniques, and this is written by William G. Cochrane. It is a very old book. Actually, when I was a student of MSc Statistics in 1972, we were taught from this book, sampling. Very simple. Even now, this book is quite valid. And for latest ideas on sampling, sampling theory, sampling error and sample size in experimental studies, surveys, comparative studies, we can also take help of Handbook of Parametric and Non-Parametric Statistical Procedures by David Seskin, and I have CRC Press 5th edition with me. It is very useful, very detailed. Actually, it is a very good book for all areas of statistics. So, I think I would advocate that you recommend to your library that this book is purchased if it is not there. One thing I must tell, that big is not necessarily better. Although I touched upon this issue of big is not necessarily better in the first lecture also, I am repeating. Increase in sample size has only one advantage. It reduces sampling error, that is estimate of standard deviation of the estimate, mean, proportion, correlation, regression coefficient or anything else. But it has so many disadvantages also. It raises non-sampling error. More units you want to include in the study, you want to increase the coverage of your study, non-sampling errors are going to increase. You have to employ more number of interviewers, and that is one reason why census results sometimes are not so reliable. Census data, I mentioned that census data on fertility is not considered to be so reliable as the data from sample registration scheme or SRS. The reason is that for conducting census of population of India, we need lakhs of investigators, and these investigators are found in primary school teachers and people of that category. they are not trained to conduct research properly, and therefore, there are various types of non-sampling issues related to how to ask a question, issues related to reducing interviewers' bias, issues related to entry on questionnaires, paper questionnaires or computer entries and so on. Then a large sample also raises cost of data collection and supervision, money, time, human resource. So, you have to compromise with the quality of researchers or interviewers, field workers. You cannot hire graduate economists, sociologists, political scientists for collecting data. You will not have so many, and for the money that you pay for collecting data. It raises the data process work also. These days with help of computers, it is however not so difficult to analyze data from population censuses of India, but earlier it used to take decades to analyze as much data or full potential of data collected from the field. Sometime the next census has started, and analysis of certain tables or certain items on the census schedule is not yet over. It takes lot of time. If you have large data, obviously cleaning of data, data entry and analysis is going to take a lot of time. So, can we calculate the optimum size? Now, the problem is this. In the first lecture also I mentioned this problem, that there are two types of errors. This is your sampling error. Sampling error being sigma by root n, as n increases, this sample size on x axis, as n increases, this is declining as sigma, a fixed quantity representing standard deviation of population units divided by square root of n. After some time, it will become parallel to x axis, asymptotic, it will become asymptotic, and there will not be much gain in terms of sampling error if you raise the sample size further. But this non-sampling error is believed to rise more and more for higher sample size. Sample size increases, non-sampling error also increases. So, if you add the two types of error, and as we have theory of sampling error, we do not have theory of non-sampling. There cannot, because non-sampling error is unpredictable and of various types. So, there cannot be a theory of non-sampling error. We can only say that for collecting large data, samples non-sampling error will be more than the sampling error, and therefore, the net error in the results would be like this U-shaped curve, this green U-shaped curve. So, as sample size increases, initially your error declines, but after reaching an optimum point, this is the point, optimum point, after that as sample size increases, total error in the results decreases, total error in the results increases, and therefore, the sample size must be fixed at this point. So, larger is not always or necessarily better. There is no formula for non-sampling errors. The decisions to reduce them are based on past learning, training, quality of interviewers, issues, how sensitive they are, whether your items suffer from social desirability, and whether there are leading questions, whether there are double barrel questions, how much is the non-response, are those people who are not responding to a particular question representative of the entire population or are of a special category. The non-sampling errors depend on the nature of questions, background, training and commitments of the investigators, back checks, supervision, quality concerns at the time of coding and analysis of data. Therefore, there is little discussion of them in sampling theory. Cochrane's book will not talk about non-sampling errors much. just that you have to exercise extreme caution at all levels, at the level of planning, at the level of fixing criteria for selecting interviewers, training, monitoring, back checks, and instruments of data collection, data entry, analysis, cleaning of data, everything. At all levels you have to exercise extreme caution. Now, in sampling theory, so we cannot talk about non-sampling error, we can only talk about sampling error, and the issue of sample size is related to sampling error. In sampling theory, sample size depends on the following considerations. Disciplinary traditions. Disciplinary traditions, in each discipline there are different traditions, and there have to be. If you are conducting a study of domestic violence in India, then the sample size considerations will be different. If you are conducting a study in medical sciences on new drugs as compared to old drugs for certain diseases, and maybe for diseases like cancer, then cancer or cardiovascular diseases, then collecting data from the patients, from caregivers, family members, doctors is extremely difficult, and getting a sample of volunteers in a hospital, you cannot go for thousands of studies. You cannot, you have to depend on say 50, 60, sometimes only 10 or 20 volunteers. So, in medical sciences, medical science is a big user of biostatistics, but the sample size there is very small. We made a study of disabled population in Kanpur. A number of disabled at one place, either you conduct first a house listing and try to find out in which houses and how many are disabled, or if you conduct a study of disabled from special institutions where disabled are trained, then you will have a limited number only. So, in that study in Kanpur we had a sample size of 85 only. It depends on the study. If you are doing a study of HIV positive people in Kanpur city, or even in a bigger city like Delhi, you may have to satisfy yourself with a study of 100, 150, 200, at most 300 or 400. But in a study of migration, you need a big sample. It also depends on the value of the parameter. If you are studying say birth rate, if you are studying attitude towards family planning, maybe you need a smaller sample, not so big. If you are studying birth rate, because birth rate is defined per thousand, 22 per thousand population, so you will need a bigger sample. If you study infant mortality rate, which is say around 60 or maybe 50 today, 50 per thousand children born, then you need a much bigger study, because to achieve the same target you have to contact more number of people, more number of households, more number of men or women. So, it depends on so many things. In sociology also there are different traditions in different sub areas of sociology, in studies of kinship, in study of religion, in studies of demography, in studies of agrarian relations. Agrarian relations are mostly studied in selected villages and sample sizes are not so large. Demographic studies are conducted on very high sample, very big sample. So, samples run into thousands and lakhs. So, within the discipline also there are so many traditions. Experimental designs, cross sectional surveys, panel study, what kind of study you are doing, it depends on that. Analysis plan, and whether you need generalizations for the entire population or you need generalizations for specific subgroups of population, that is also important. And like in socioeconomic surveys, whether you need generalization for India is one thing, whether you need generalization for all the states, that is another thing, whether you need generalization for district level, that is another thing, and whether you need generalizations at city level or household level in rural areas or at the level of slums. You need different sizes of sample for different units, and whether your variables are qualitative or numeric. Qualitative variables you are dealing with produce percentages, frequencies, proportions, ratios, and numeric variables are measured on interval or ratio scale. The amount of error that can be tolerated in major variables. In what proportion of cases? This what proportion of cases means, suppose your sample estimate of a proportion is small p, and the real value, we do not know what the real value of p is, but let us assume that the value of p, true value of p in the population is capital P. Then the probability that small p and capital P differ by a quantity more than d, d will be a small quantity, we do not want our p to differ from capital P too much. That probability of difference in small p minus capital P being more than d is a small probability alpha. So, two things have to be defined, one d and second alpha. D means how much error you can tolerate, and alpha means in what proportion of cases. Similarly, if you are dealing with numeric variables and you are looking for estimates of mean, then you look for that the difference between sample mean and true value of mean of the population, mu is the true value of mean in the population. The principle of sampling is that sample should give sample on the basis of study of a small number of cases should yield the representative values of the population. So, the difference between sample mean and true value of population mean divided by sample means relative difference between sample mean and true mean is greater than r, some value fixed by you, r is alpha, again a small probability. You define that okay, I will be happy if fertility in India whatever it is 2.5, 2.4 whatever, my sample estimate if it differs from true value of fertility divided by sample mean or either sample mean or true value of fertility is greater than 5% should not be more than 1% or 2%, that kind of a statement. So, one, how much error in the results you are willing to tolerate. These are two very important questions in determining sample size. How much absolute or relative error, this p minus p is a case of absolute difference, this sample mean minus mu divided by sample mean is a case of, or this in denominator sample mean can be replaced by population mean, this is a case of relative error. So, absolute error in the results or relative error in the results exceeds d or r, a fixed number should be alpha or less. D and R are determined by alpha and the distribution of p or sample mean. Sometimes we also consider type 2 error or beta. Then in the previous lecture I said that we determine first sample size for simple random sampling even when we are using cluster sampling, and then for clustering effect of units we calculate design effect or we assume design effect to be something between 2 and 4. Cochrane suggests that clustering effect should yield a ratio of variance in the cluster sampling to variance in simple random sampling around 2.5. 2 to 4 can be the design effect. If it is 2 to 4, then it means that the size of cluster sampling or your sample design, your practical sample design should be 2 to 4 times what you will need for a simple random sample. Then there are practical issues like resources available, cost of sampling, time frame, in how much time you want results. Sometimes governments want very quick results, sometimes you can do your research leisurely. If you are a PhD student, you can spend 1 year or even more in collecting data, and nature of population. Design effect is defined as ratio of variance of the estimate for the design used in the study to that estimated for the simple random sampling. NFHS, various rounds of NFHS have presented standard error as well as design effect for each item. A design effect of 3.0 means that the variance of design used by you is 3 times it would be if simple random sampling method was used. In other words, a SRS of 1/3 size would be equally good, means a simple random sample of size 1/3 of what you are doing is equally good. Sample size is design effect of the complex design or practical design that you are using and multiplied by sample size for a simple random sample. So, in calculation of sample size, you will calculate simple random sample size and multiply this by design effect if you are using cluster sampling or multi-stage sampling. And for simple random sampling, you take the decision of sample size on the basis of how much error in the results you can tolerate. I have given 2 formulae, one for proportion, another for sample mean, but similar formulae can be developed for correlation coefficient, regression coefficient or other things, harmonic mean, geometric mean, variance itself or range or anything that you want to estimate from the sample. In simple random sample, when studying proportions, Cochrane shows it is mathematically derived, it is not arbitrary, it is not subjective, it is mathematically derived that the sample size n will be equal to T square capital P capital Q divided by D square, whole thing divided by 1 plus the same expression T square P Q by D square minus 1 divided by capital N. Now, P is proportion in the population, Q is 1 minus P, D is the difference amount of error that can be tolerated, and T is the normal quantile corresponding to a probability of type 1 error of alpha. I said that 2 things are fixed. One, how much error you can tolerate, that is D. In case of relative errors, it is R, but then formula will be slightly changed. So, n equal to T square. T is normal quantile corresponding to a given value of alpha. Like in a normal distribution for alpha at 0.05, T value of T would be 1.96. If alpha is 0.05 and you are considering errors on both the sides, then T would be 1.96, like that. So, by using this formula you can calculate the value of n. If capital N is very large, means population is large, or the sample fraction small n by capital N is very small, then n reduces to T square P Q by D square. Cochrane suggests that you first calculate this part T square P Q by D square, and then sample size is for using this formula you can calculate n equal to this, if we call this as n 0, then n equal to n 0 divided by 1 plus n0 by n. I think this is quite good. It is a good approximation of sample size required for difference d and probability of exceeding the difference being alpha. So, in case of numeric values, when you are studying numeric data like mean, so there n would be t squared. The meaning of t is same. T is the quantile value for alpha, and capital S square is variance of the population. D is the difference that you can tolerate, and capital N is the population size. D is not a relative error, D is amount of error that can be tolerated, absolute error, as in P. And again you calculate n or n0 as t square s square by d square, and then sample size n equal to n0 divided by 1 plus n0 by n. Your second sample size will be still lower, and that can be equally good if sample fraction is not very small or if population is not very large. Now, you may ask a question that okay, this formula is okay. On the right hand side of this formula, t can be known by consulting normal distribution table. For t is that value of quantile beyond which alpha percent error lies. D is the error that we fix, absolute error we fix in results, sample results, and the true value of the population parameters. But how do we know capital S square, or in case of proportions, how do we know capital P and capital Q? We are trying to estimate capital P from the sample. If we knew P, capital P, then we would not conduct the sample study. Or in case of numeric data, we do not know capital S square. If we had known capital S square, we would also have known the mean, true mean of the population. So, what is and Cochrane suggests that in sampling theory we have to work with our single sample that we have at our hand. So, in sampling theory, capital P or capital Q or capital S square are to be replaced by their estimates from the sample itself. So, capital P will be replaced by small p, where small p is the proportion obtained from the sample. Capital S square will be replaced by small s square, where small s square will be the variance of units included in the sample. So, that also means that before conducting a bigger or main study, you have to conduct a pilot study from which estimates of capital P, capital Q or capital S square can be obtained, or maybe in some other area or in a different region. Such study was already done in the past, from where you can take estimates of P and Q or S square. Maybe you are studying something on which studies have already been made in conditions similar to those of India. So, you can take P, Q and S square from those countries. Otherwise, if no data are available, then you conduct a pilot study, and in pilot study on a smaller sample, you try to get simply tentative estimates of P, Q and S square and use them for calculating sample size, and then a final study of this sample size is conducted. In an article in Demography India in 2014, it cannot be 1914. There was no Demography India in 1914. In 2014, in volume 43 of Demography India, Fauzdar Ram used the following formula for minimum sample size. Fauzdar Ram was the director of International Institute of Population Sciences and a noted demographer. His formula was that n equal to 1 upon alpha square Q upon P into Deft square. alpha is the probability of error that we are willing to tolerate, q is 1 minus p, and p is the true value of population proportion, which is replaced by small p in calculation of sample size, and deft is an assumed deft, assumed design effect as ratio of standard errors. He defined this design effect as ratio of standard errors, though in Cochrane's book design effect is defined as ratio of variances. Not it will not affect too much your considerations of sample size, but I just pointed out that there was a difference in Fodder-Rams definition and in the definition given by Cochrane. Cochrane is based on real mathematical grounds. For alpha equal to 0.05 and p equal to 0.60, suppose you are trying to estimate something whose estimate in the population is 0.60, then q is 0.40 and his deft square is 3, this deft square design effect. If deft square is 3, then n is 800. So, if you are trying to make a study of some proportion which is close to 60% and deft square is 3, then for alpha equal to 0.05 you need a sample of size 800. Obviously, if deft is more, then a bigger sample will be required. If alpha is more, then lesser sample is required. If q by p is more, then a bigger sample is required. So, I thought that I can discuss this formula of Demography India 2014. When population parameters are not known, then we estimate them p s square. Just now I said from pilot study or from studies available in other parts of the world. If you are considering both alpha and beta, means type 1 error as well as type 2 error. These days in determining sample size, we not only consider alpha, we also consider beta. You will not find references to this at so many places. When we were students, like then only alpha was considered, but these days when you submit research proposal, if you also include beta, then you will leave the impression as you are more familiar with advanced theory of sampling, and in that case t square will be replaced by t1 square plus t2 square. T1 corresponds to alpha and T2 to beta. And normally we try to fix alpha and then after that we fix beta. Some books suggest that alpha being more serious, you fix alpha at say 5% and beta type 2 error can be 4 times the type 1 error. You can afford to have beta 4 times the type 1 error. What is beta? Beta is the probability of not rejecting the null hypothesis when an alternative hypothesis is true. That is also an error, but that is considered to be less serious an error. Ultimately, the goal of sampling theory is to increase power of the test of 1 minus beta, which means probability of rejecting a false hypothesis. So, t square is replaced by t1 square and t2 square. The first term corresponds to alpha, the second to beta. For this, an alternative hypothesis has to be, for beta you have to have an alternative hypothesis, but like t1 is the value of quantile, normal quantile at 0.05 one side test, and T2 is the value at 20% again one side, and then T square is replaced by T1 square plus T2 square. The above formulae are based on the assumption that sample is simple random. If sample is not simple random, we have to estimate design effect or clustering effect of the design and multiply the value of n as obtained through the above formula by design effect, often in the range of 2 to 4. I am repeating this because these things are not commonly found in sociological methodology books. In sociology books, generally for determining sample size, sigma by root n standard error formula is mentioned, but not in details what is the logic. That logic is based on two considerations. If you are able to say even this much in the interviews, that sample size is fixed by considering two things: how much error can be tolerated in the results and in what proportion of cases, I think you will leave a good impression. And then in sociology, we know that due to background, our students are not so comfortable with formulae, mathematics, they are phobic of statistics, but at least conceptually you can tell that yes, there are two things. The soul of sampling theory is standard error, and sample size is determined by fixing two things: how much error we are going to tolerate in the results and in what proportion of cases. And Cochrane develops a formula for determining sample size. Then it is you can say that you have forgotten the formula, but it will also be good if you can remember this. You need not go into the mathematical logic of this, but if you can remember the formula for proportion at least for very large population, ignoring the finite population correction factor, that will be great. In stratified sampling with optimum allocation, the sample size is this: n equal to C minus C0 sigma NH, capital NH, capital SH divided by root CH divided by sigma NH SH root CH. C0 is the fixed cost and CH is the cost per unit in the hth stratum. Power of the test I mentioned is related to type 2 error or beta. Some statisticians have also developed formulae for sample size based on precision, type 1 error as well as type 2 error, and effect size. The D, effect size is not a new thing. Effect size is what I am represented by D. In formula for population proportions, I said small p minus capital P, absolute value of that is greater than or equal to D. That D is the effect size. The issue would be like this: in real terms, if you are sponsored a project by government on evaluation of some operations research, like operation research or monitoring and evaluation of a program, they want to know whether extension education through media has improved people's awareness of say swachhata or cleanliness. So, you deal with some variables of cleanliness, say what proportion of people are aware of importance of cleanliness, what proportion of people go for open defecation and so on. This D is obtained by fixing how much minimum effect of extension education programs you want to see, you want to notice, that you can see if the difference in baseline study and after implementation of extension education program, what proportion is observed in the second study, baseline study, end line study, the difference. And you will say that we will call a difference significance, or we will say that there is an effect of the program if the difference is this much, that that is called effect size. So, D another way, this is another way of defining D. One way of defining D would be how much error in the results you can tolerate. Another way of defining D would be what is your effect size. You fix effect size. These days we in sending proposals we write more sophisticated formulae considering as tentative estimates of proportions or means, variances, and design effects, effect size, and type 1 error, type 2 error, alpha and beta. So, T1 for alpha, T2 for alpha, and we also make allowance for non-response, non-contact, non-response. There will always be some percentage of cases of refusals, and if you want a sample of say size 400, you have to give an allowance for that certain percentage of people are going to refuse to give interview. So, maybe if you interview 450, if you reach 450 people, 50 people refuse and you get a sample of size, effective sample size is 400. So, by fixing on the basis of past surveys, ratios of non-contacts, refusals, non-response, you have to raise your sample size. So, all these things have to be considered. Let me repeat what things have to be considered: effect size, or how much error in the results you can tolerate, in what proportion of cases, what is your alpha, what is your beta, and what is your understanding of non-response or refusal rates. Then you determine sample size. There are some tips for selecting sample depending on characteristics of items. If the item that you are studying is widespread throughout the region, occurring with reasonable frequency, then type of sampling needed would be a general survey with low sampling ratio. Low sampling ratio because it is widespread. From all parts of the population you will get some observations. Frequency is reasonable in all parts, and therefore, a low sampling ratio will work. Although sampling ratio is low, means sample size to population size is low, but because something is occurring with reasonable frequency in all parts of the population, so sample size would be okay. If something is widespread throughout the region, but occurring with low frequency, then a general survey with a higher sampling ratio will be required. If there is reasonable frequency, then a low sampling ratio will do. But if the frequency is low, something occurring throughout the region, but with low frequency, then a higher sampling ratio will be required. This means if you are studying infant mortality, then a bigger sample will be required. If you are studying birth rate, then a smaller sample will do, and if you are studying say awareness of family planning, then still a smaller sample size can do. There may be something occurring with reasonable frequency in most parts, but with more sporadic distribution, being absent in some parts and highly concentrated in other parts. Something is concentrated in some parts, although frequency is reasonable, but it is concentrated in some parts and absent in other parts. So, obviously, stratified sample with different intensities in different parts or different sample fractions in different parts will be required. It is a case of heterogeneous population, and something is sporadic, means absent in some parts and highly concentrated in other parts. So, there are differences. If maybe if you are studying suicide, for example, suicide rate among farmers. Now, suicide rates among farmers are not same in all parts of the country, in all states, in all the regions. They are more in some regions and less in other regions. So, you need a stratified sample. Make two strata, one stratum of those states where suicide rate among farmers is high and another stratum where suicide rate among farmers is low. Stratified samples with different intensities. In areas where suicide rate is low, you will need a bigger sample, and in states or regions where suicide rate is high, a smaller sample can do. Then distribution may be sporadic or concentrated in a small part of the region, very sporadic or concentrated in a small part of the region. This is not suitable for a general survey. This requires sample geared to its distribution. There is some phenomenon, and like communal riots are found in certain states of India, and in those states also they are concentrated in some cities or some districts. So, distribution is very sporadic. It is not found in all the states, all the cities. There are some states where communal riots occur more frequently, and among in those states also some districts or some urban wards or some rural areas are more susceptible to communal riots. So, in study of communal riots, a general survey would not be required, it is not suitable. It requires a sample geared to its distribution. We will we can collect more data from UP, from Bihar, from Gujarat, from those states where communal riots occur more frequently, and we will require no sample or a small sample from Kerala or Himachal Pradesh or northeast where such riots do not occur. There in northeast of course there are tribal conflicts, but Hindu-Muslim type of communal riots are not there. Sampling for two or more items. Sometime in the same study you are interested in two or more items. Then in most surveys information is collected on more than one item. Sometimes your questionnaire runs into 25, 30, 50 pages. Recently I met a student of mine who is conducting a big study in Gujarat on socioeconomic characteristics and health profile. Biometric measurements are taken along with socioeconomic surveys, and he was telling me that his questionnaire runs into more than 100 pages. So, sometimes you have two or more, two is very small a number, maybe 50 or more items in the same survey. Sometimes the number of items is large. For example, family health survey includes many variables such as age, income, family size, family planning, safe childbirth and so on. In that case, if a desired degree of precision is prescribed for each item, the calculations lead to a series of conflicting values of n. For some item, they will show that you need a sample size of 25,000, for some you need a sample size of 30,000, for some 60,000, for some 5,000. One for each item, one sample size for each item. It may happen that the n's required are all reasonably close, then it is good. If the largest of the n's falls within the limits of the budget, then this n is selected. Largest n is selected. If you can afford to spend so much money that is required for largest value of n, select that n. More commonly, there is a sufficient variation among the n's, so that we are reluctant to choose the largest, either from budgetary considerations or because this will give an overall standard of precision substantially higher than originally contemplated. In this event, the desired standard of precision may be relaxed for certain of the items in order to permit the use of a smaller value n. In practice, when you submit a research proposal, although research proposals are submitted by senior faculty members, but you students may submit a research proposal to your supervisor for MA or MPhil thesis. Then focus on technical details, plan the administrative details, minimize cost at all levels. When we submit our proposals, then we look at everything, all costs, salaries of staff, research associates, investigators, field workers, travel, how much TADA will be required, development of tools, questionnaires, interview schedules, their printing, then conducting workshops, or you yourself, I myself attending workshops outside to present findings of our study, and some miscellaneous costs. Then you have to quote per unit household basis, and remember that the sponsors are going to look first at the technical details. So, you should be perfect in technical details of your study, and then they will go according to minimum quotations. So, you have to be careful at both the levels, technical details of the study. If you can show that you have very carefully, judiciously, carefully selected your sample size, keeping in view these things, and also minimize cost of conducting the study at all levels. So, you are having a higher chance of getting accepted by the sponsor. Thank you very much.